First, we're going to work on the negative rule. What if you're doing an inequality equation that uses a negative number? The way it works is you solve as if a normal equation. So you would get x and negative 2. However, the rule is that when working with this, whenever you divide by a negative, you have to flip your sign. So a greater than would become a less than symbol, and a less than would become a greater than symbol. So here we have x is less than or equal to negative 2. Here's y on a number line. Here we have negative 2, 0, and 2. If we were to keep it as greater than or equal to 2, we would fill it in on negative 2, but it would be going greater than. So we would be going this way. So that means any number greater than negative 2 should work out in this equation. If we plug in negative 1, negative 6 times negative 1 is 6. 6 is not greater than 12. If we plug in 2, 2 times negative 6 is negative 12, which is not greater than 12. However, when we flip the sign and make it x is less than negative 2, and we go the other way, if we plug in negative 3 times negative 6 is 18, which is greater than 12. Negative 10 even. Negative 10 times negative 6 is 60, which is greater than 12. That's the reason why you flip your sign. And it works the same way with a less than sign. Here we have negative 12x is less than 60. Here we divide out negative 12, divide out negative 12, x, and then 60 divided by negative 12 is negative 5. And here we have a less than symbol, we're going to switch it to a greater than symbol. So our solution set is x is greater than negative 5. Again, to prove it, that rule on a number line, here we have 5, here we have 0, here we have negative 5, and let's just throw in negative 6, it'll make it easier on us. So, we know that this is just a greater than sign, so we're going to have an open circle on negative 5 because it doesn't actually equal negative 5. If we were to have done it less than, it would have gone this way, towards the negatives. Here we have, let's say, negative 6. If we plug in negative 6 times negative 12 is 72, which is not less than 60. Positive 72 is not less than 70. But if we apply our rule and we do it the other way, and we go to the right, to the greater than sign, let's plug in any number. Let's say we plug in 1. 1 times negative 12 is less than 60 because negative 12 is less than 60. If we plug in, let's say, 20. 20 times negative 12 is negative 240, which is still less than 60. That's why you do that rule. The addition property for inequality, if we have A is greater than B, and we add C, A plus C is still going to be greater than B plus C. If we use an actual numerical example, say 3 is greater than 2, and let's say C is 4. 3 plus 4 is greater than 2 plus 4, which is still 7 is greater than 6. So it works out. For multiplication, if we have A is greater than B, the rule is that K times A is greater than K times B. Only when there's a positive number. If we have, let's say, A is still 3 and B is 2, and let's say K equals 7. So we have 7 times 3 is greater than 7 times 2, 21 is greater than 14. But if we put in a negative number, 7, let's make K negative 7. Negative 7 times 3 is greater than negative 7 times 2. Negative 21, is negative 21 greater than negative 14? It's not. It's less than. So whenever you multiply by a negative number, you have to switch the sign. Negative 21 is less than negative 14. What you do is you reverse the greater than symbol to a less than symbol, or a less than symbol to a greater than symbol whenever you're dividing by a negative number. Now let's work with if we have a squared inequality. If I have x squared is greater than or equal to 36, again, we treat it like a regular equation. We get the square root, and we would have x is greater than or equal to 6. But in this case, we're actually going to have x is less than or equal to -6. Because don't forget, whenever you take a square root, you have to have the positive and negative number. Because -6 times -6 makes a positive 36. So, the reason why we're switching this is for the exact same reason with when dividing by a negative number. Technically, this is the same thing as dividing out -6. So 36 divided by -6 equals -6. So because let's say this was an inequality, because we're dividing by a negative, this sign has to switch. That's the reason behind it. All because we're technically dividing by a negative number, so when you're dividing or taking the root of a number and you use it, okay. So just like when dividing by a negative number, when you take the root of a number to get a negative number, you have to flip the sign. Exact same rule, and here's why. If we were to do it, keep it the same direction at -6 and 6, we know that it's equal to, so we fill in the circle. If we did greater than and greater than here, it would be the same thing as saying, oh yeah, we could have just put greater than -6. And when you plug in the solutions, it doesn't work. Let's say we have 7. 7 squared. Okay. When we plug in the solution set for this, when we do greater than 6, 7 times 7 is 49, which is greater than or equal to 36. But on the negative side, when we follow, okay. But here, if we were to make it greater than, and make it x is greater than or equal to, oh god, this is confusing me. Whew. Okay. But if we plugged in any of these values, let's say 0, 0 times 0 is 0, which is not greater than or equal to 36. That is why, again, we have to go and switch the sign and make it less than -6, because when you plug in a number smaller than -6, such as -9, -9 times -9 makes positive 81, which is greater than 36. Therefore, it's the same rule. Hey, thanks for watching this Crash Course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.